Good morning or good afternoon, depends on where you are. My name is Mary Ressler, and I'm the Councils and Component Specialist for IFMA. I'd like to thank you for calling in today for this webinar brought to us by the Corporate Facilities Council. At this time, I'd like to introduce our presenter, Paul Schultz. Paul has worked in residential and commercial irrigation since 1985. He is a certified irrigation contractor, certified landscape irrigation auditor, certified landscape technician for irrigation installation, as well as a Bay-friendly qualified landscape professional and a CLCA certified water manager. Paul serves as the irrigation resource manager for Cagwin and Dorward, which includes evaluating landscape water conservation projects and educating customers and staff on effective landscape water management. He meets regularly with homeowners associations, property management companies, and is actively involved in state and local water management advisory groups. Paul has spoken on behalf of the California Landscape Contractors Association before a California State Senate subcommittee on addressing the impending water crisis in California. And at this time, Paul, I will turn it over to you.
Thank you very much, Mary, and good morning to everyone. I want to thank you for your interest in this important topic. And we thought we'd start with a quick look at understanding some of the logos that should be on your screen. These logos represent what professional landscapers, they're basically an evidence of a company's commitment to quality service, and specifically in the areas of water management. So in the upper left, starting there, is a certified landscape irrigation auditor, somebody who can go in and verify the performance of an irrigation system, including testing of the irrigation coverage. CLCA stands for the California Landscape Contractors Association. They have a certified landscape water manager program. The Irrigation Association and the CLCA work with the EPA for water standards. Another one that's through stopwaste.org is the Bay-friendly, in some places also known as river-friendly. It's a holistic landscape approach using organic and low-impact type landscape projects. And then we have Planet as a certified landscape irrigation and industry professionals. And so there's a variety of different professional designations that if you're working in either through California or throughout the United States, should be looking for these types of designations. When we focus on just water, we realize it often is very taken for granted. We turn on the faucet and it just opens up freely. So the question is, what percentage of the Earth's water is available for use? Well, I think you'd be surprised to find out it's really only 1% of the Earth's water is available, and most of that is 99% is through oceans, which is salt water and Arctic ice, making up the 99%. So in there is urban agriculture and ecosystems that share the same 1%. And with California's history of droughts, this balance of trying to keep everybody happy has been a challenge. Well, when we focus on just urban water use needs, water supplies need to be updated to keep up with the demand, so growing population. Water rates then tend to rise, and in our area, they don't go down. So several water districts throughout the state of California are forecasting doubling and even quadrupling their water rates over the next 10 years. And after a review by the state of California looking at the population growth and its history of droughts, the state of California said, hey, we've got a water crisis, and this is true even in wet years. The studies by the state and federal agencies reveal that among other things, there's approximately a 20% of water use in landscaping that is wasted. We found this on the internet. This is for the Marin Municipal Water District. That's up in the San Francisco Bay Area. And if you'll take a look at the tiered water rates, they're basically designed to encourage water conservation for residential customers. So just kind of looking and understanding something that's there. If you look in the column, it says current rate per CCF. CCF stands for 100 cubic feet, which is the equivalent of 748 gallons. So as water districts set what are called water budgets, which we'll come back to, they determine how much a site should be using. anything over that or parameters of certain amounts of water, then they have an increased rate. And in some cases, they're going up significantly, as you can see under Tier 4. Another slide, again from MMWD, shows the research that they did in comparing themselves to other agencies. And if you look up in Northern California, we have some that in the Sacramento and Marysville area where they've not had water meters before. State is now requiring that water meters be installed, and so there's a dramatic jump in the cost of water. As an average then for Northern California, we're looking at roughly a 17% rate increase in a 1-year period, and in Southern California we're looking at roughly a 13% rate increase. In order to address the state's water crisis, California has put into place several pieces of legislation, and we'll just cover a couple. One is referred to as SBX 7-7, also commonly known as 20 by 2020. And what this does is mandates a 20% reduction in water use by each water district by the year 2020. And each water district then has to be able to show its plan for doing so in order for it to continue to receive state grants and funding. In fact, by the year 2015, which is just about 2 to 3 years away here, they have to have show that they've got a plan in place and that they're on track with a 10% reduction so that they don't lose valuable state funding and grants. Many of the water districts look at their largest customers then and the sites where water use appears to be high to try and meet these goals. So large landscapes are a big target. If we look at another piece of the legislation, another one is AB 1881. It's known as the Water Efficient Landscape Ordinance, or WELO for short, and it affects new landscape projects and requires more local municipal oversight to make sure planting and irrigation system meet newer standards. Calculations are then required to be met in order to show how much water these sites will be using and that they are below the calculated maximums. So then our job then is to envision how the new water and environmental requirements costs will impact our customers. How do we help them be prepared? What will their landscapes need to look like in the future? So here's a great example of a prior area with about roughly 8 acres worth of grass, and now sites that are now looking more like this. It's still attractive, but now have a different appearance. Older sites will likely experience significant increased costs and penalties due to inefficient irrigation and also pressure then to reduce large turf areas. And properties will then face the challenge of how to keep the cost down while helping transition sites to meet the new watering requirements. Many customers feel that costs are prohibitive to making the new required changes, and the budgets are typically tight, especially in California with the economy. The good news is most sites can start reducing landscape water costs right now with minimal out-of-pocket costs. In fact, with immediate savings, there's some recommended ways in which they can do that. They need to first maintain the existing irrigation system by making sure that timely approval of necessary repairs. Leaks that continue on for several weeks can start to add up to several thousands of dollars over time. Use replacement parts that are consistent with the existing system hardware. So mixing and matching is kind of a no-no because different manufacturers have different specifications for their nozzles and products. You have to work very hard to make sure that they are not mismatched. Make sure that the sprinkler heads are not tilted or obstructed. Use correctly sized nozzles and head placement to avoid overspray. Make sure that the manufacturer's recommended pressure range for the sprinklers is adhered to. Waste can come from either too low, where it creates on large rotors creates what we call a donut effect, or too high, where you get what's called fogging, excessive pressure to where the droplets are so small that they actually become airborne and just drift off to the side. You want to perform regular system checks to verify the system is operating properly, and perform schedule controllers to avoid excessive run times that contribute to runoff and overwatering. When we look at something called distribution uniformity, which is how evenly water is applied. What you want to look at is maintaining the integrity of the system or improving it so that you avoid overwatering and increasing landscape water costs. So when we look at this chart, if we say that a site is watering at 75% efficiency, which is really actually very good, we need to apply 133% of what the plant needs to have in order to stay green. Unfortunately, at 40%, this is not good, and this is typical of older sites or projects where the irrigation system has not been maintained properly. So you would need to apply roughly 250% of the what the plant needs, or in other words, 2.5 times what the plant needs in order for you to manage, say, turf dry areas. By the way, this is a slide that was provided to us by the city of Santa Rosa in California. To compensate for hot spots and plant stress, controllers are then dialed up in order to avoid, to flood irrigate to cover the hot spots. Excessive applications of fertilizers are then applied to help bring back the struggling plant appearance. And then this becomes a vicious cycle of where you have to fix it because you're not fixing the original problem, which is poor coverage. So to improve coverage, replacement materials, again, should help reduce water waste. Pressure compensating nozzles can help reduce the fogging and provide more of a matched precipitation. Heads that are closer to a valve are going to have higher pressure than ones further away. So the pressure compensating helps keep the even coverage throughout the same irrigation zone. Move or add sprinklers to improve head-to-head coverage and replace older sprinkler heads with newer ones that include check valves. And these allow for the water to shut off at the end of a cycle and capture the water inside the piping versus allowing it to drain out at the lowest sprinkler heads. In addition to improving irrigation performance, consider using a holistic landscape approach such as bay-friendly that practices that improve soil health, which includes then strengthening the roots of the plants, which capture then more water and help improve plant appearance. When we speak about efficiency of irrigation system as a whole, here's what we're talking about. Head-to-head coverage means placing heads evenly apart to apply water as an even layer and help avoid hot spots. So as you look at the cups down below, you can see that due to the overlap, we now have an even layer of water. How evenly a system applies this water is referred to, again, as distribution uniformity, or DU for short. Again, quality repairs and maintaining the manufacturer's recommended pressure are very important in maintaining a higher DU. We do testing of this through a process where we can audit the irrigation system, again, measuring. So what we do is we typically place flags at the different sprinkler heads. We place cups then evenly throughout the area. We run the sprinkler system for a set amount of time and then record the amount of time and the water captured in each of the cups. Audits are typically done when the water district is qualifying a site for rebates or when addressing customers who are using excessive amounts of water, or when installing new landscapes under AB 1881. Many of the water districts are starting to require audits to confirm performance compliance. Now, this may be the first time you have seen this equation. What it stands for is estimated total water use. It's not something that we're expecting people to go out and start using right away, but it is for you to be able to be aware that there's such formulas that allow people to calculate a water budget. And a water budget in itself is basically determining how much water is actually needed by an existing landscape, and that way you can determine if you're watering too much. It allows you then to better underline what's causing that if you're going over that water budget. So this is an example of evapotranspiration, which we'll talk about a little bit later, but in a nutshell, it's the amount of water loss into the environment on a daily and then, of course, cumulatively over a year from the plant material and from the soils. So if we look at this sample in Sacramento, California, we're looking at 20,000 square feet of what's called cool season turf with a 50% distribution uniformity, and 50,000 square feet of shrubs with a 35% distribution uniformity. And something like that we might see where sprinkler heads and the plants were installed when they were small, and then as the plant material kind of grew in and filled in, the sprinkler heads are basically blocked significantly. On something like this, based on that calculation, we would be using roughly 3.5 million gallons of water per year. Just by improving the distribution uniformity, you can see the impact of water savings. So in here, we might say that for the turf, we're going to go ahead and move some heads and add maybe some types of nozzles that allow for good head-to-head coverage, low overspray, low loss to misting. And we might take the shrub areas and run some drip tubing that will allow the root zones to get the water directly. It's not going to be blocked by the foliage, and it's not going to be affected by wind. As you can see, then, that's quite a significant reduction in water just by modifying just the irrigation system alone. So this is evapotranspiration, and this is basically, we've looked at now the performance of irrigation systems, but we're now going to then focus on more on the side of what the landscape needs. So understanding how much water a plant actually needs and the opportunity for savings, we've got to learn about evapotranspiration, or ET for short. So ET is the water loss from landscape due to weather factors such as sunlight, wind, humidity, and temperature, which cause evaporation from the soil and plant surfaces and transpiration by plants. And the important thing to realize is that ET changes as the weather changes. In fact, it changes on a daily basis. We can have days where it's very hot one day and very cool. And so that water loss changes on a daily basis. If we were to take the average sum, say, of ET loss and also look at rainfall for, and again, another area up in the Northern California area towards Sacramento, we can see that this reference ET data shows how little water is being evaporated during the winter times when it's cool and wet, and then ramps up dramatically until it hits peak in July and then goes back down. We call this a normal ET cycle. Overlapped in that then is the ability to see the rainfall that overlaps onto that, so that you can see that, of course, during the winter times, more times that it's going to be the rainfall that's going to take care of the watering needs for the plant material. So the purpose then of maintaining the site's landscape is referred to as far as tracking, and the amount of water that's needed is referred to a water budget. And then the whole job of a sprinkler system is to put back that water that's lost to ET. So when you have a budget and you know what's needing to be put back, it's easier then to determine if you are overwatering a site. This shows you a little bit about how when you have a reference ET, not all plants use the same type of plant material. So high water use plants would include things like turf and annuals and willows, which is about 70 to 80% of ET. Medium water use plants such as typical shrubs would use about 40 to 60% of ET, and then the low water use plants, which we sometimes refer to as drought tolerant or California natives, use about 10 to 30% of ET. This is an example of a landscape design that shows that you can see how the site is actually then broken up into high, medium, and low water use plants. This serves as a twofold. First off, irrigation systems, you want to make sure that they're unique to those areas and include things like shading and so forth. But as you measure those different high, medium, and low water use areas, you can apply the formula that we looked at earlier to help create a water budget. And this is an example then that of a water budget. Many of the water districts in Northern California are starting to provide some of the larger sites with a water budget, and again, they may price their water based on it. If not, different organizations such as CLCA, through their Certified Water Manager program, are able to help. Here's an example of one on a site, and what you're looking at then is the top line that's above everything represents the budget of a maximum what would be recommended for each of the months, as shown in initials across the bottom. The next line, it's kind of a green line there, shows what 80%, and this is 80% of the ET, and that's a goal by the state of California. The blue line then represents how this actual site did for each month in watering compared to the other lines. Each month that the irrigation water meter is actually being read by our landscape folks. They go and they actually look at the meter and then record that on the CLCA website. The landscaper and then the customer can also then look at this and compare use to budget. The landscaper is now more engaged, and the customer is hopefully as well, because now the landscaper can compare usage to budget. They can start looking at programming. If there's excessive water use and the programming looks okay, then they might start looking for leaks and start to look for options for helping reduce consumption and improving coverage. Again, by knowing your budget, this helps avoid dialing up the amount of usage on the irrigation timer just to cover hotspots instead of bringing it down to where it should be. And so your site is essentially using more water than necessary. And I don't know how many people are aware of this, but if you can drown a plant. So too much water can actually be bad for a plant. And so, and if you have excessive water in there, what you're doing is you're creating what's called anaerobic, or basically killing the beneficial microbes that are down in the soil and causing a rotting environment. Soils can actually smell. So excessive water actually can do a lot of damage and bring in a lot of unwanted pests and funguses and so forth. In many cases, when we're walking a landscape, we actually see the visual cues that water site is being overwatered. These sites, the clues include oversaturated soils. In many cases, we'll see lawnmower ruts. We'll see algae and moss build up in the gutters along the sidewalks and driveways, and inside even the planting areas. Overwatering will contribute to stunted plant growth. Runoff tends to stain and show overspray patterns on the adjacent hardscape. Damage to asphalt and siding and concrete is apparent, and we'll tend to also see surface roots due to excessive short daily cycles. So the cost of watering is often ignored and falls under the radar, and it's not generally seen being connected to landscape management. So this slide here basically looks at the cost of landscape maintenance, which in many larger sites is probably one of the larger cost items on a site's budget. This is their maintenance expenses that they have for a site. Landscape maintenance it tends to be at the top of the list, followed closely by water. But unfortunately, a lot of times water is not seen as being directly connected to the maintenance. And so what we want to do is be able to show that it's actually a combination. We want people to think about landscape maintenance and landscape water being a combined cost. And under proper water management, if water usage can be reduced, say, by 28%, you're actually looking at a savings about, in this comparison, of roughly about 2 months' worth of maintenance cost. So that water management actually helps pay for itself. We start to look at the different technologies that are out there to help reduce water waste. So these are some of the newer things that are available, or actually have been around for a while, but people are starting to understand how they work. Rotary stream nozzles can replace existing spray nozzles. These are the smaller pop-ups we tend to see in the turf areas. And they basically improve head-to-head coverage. They help reduce runoff because the droplets are being applied at a lower rate. They also improve low pressure issues because in many cases when sprinkler systems maybe were designed, they put too many sprinkler heads on, and so the volume of water that's going out is more than the system can deliver. So the pressure tends to be low. So by reducing the amount of flow, we can actually get better coverage. The trade-off is essentially that you have to run it longer. And it also helps reduce runoff because the application rate for the nozzles are at a lower rate than spray heads. Another one is inline dripper tubing. Many are familiar with drip systems that have individual emitters that come off with what we call spaghetti tubing and go to individual plants. There's a little different approach to it. It basically is applied in a grid onto the ground, and the overlap, as you can see in the illustration, allows for even coverage. This, again, is being placed at a closer area to the root zone and more evenly, and it helps water small areas avoid overspray and wind drift. This is really important, especially in shrub areas or in narrow turf areas, and also around buildings and siding to avoid damage. So this in itself helps not only reduce water waste, but it also reduces maintenance costs due to minimal moving parts compared to the pop-up sprinklers. Plus, it also reduces cost associated with overspray onto buildings and damage that has to be covered somehow in the future. Another type of technology is smart controllers, and we're starting to see some of those. So a smart controller, basically what it's designed to do is emulate the weather. It takes individual station information and tries to keep it at the optimum level, and thereby the programming that it creates reduces runoff, and so there's less damage to pavement and fences and buildings. And also by putting down the appropriate amount of water, you avoid plant diseases and pest issues from insects. Also allows the soil to get an appropriate amount of air in there, so again we don't have the issue with the anaerobic soils. And the net result, of course, is lower water bills and reduced energy costs. And they fall into about three main categories. Ones that are dealing with a weather signal coming from a satellite. You can also get a sensor that's on site. And there are smart controllers that actually are moisture sensors that can be placed down in the root zone to determine when it's an appropriate amount of water being applied. Another important thing is when you're converting areas or you're making sure that you're applying the right amount, going back to this drawing here, it's really, really important that if you have a low water use area, that your plants all in that area have that same watering need. If you have a high water use need in a low water use area, you're going to either lose that plant because it's not going to get enough water, or you're going to have to overwater to compensate. So it's better to make sure that those areas are separated. In fact, again, going back to the legislation when designing new landscapes, this has to be adhered to very closely. So they want to know the types of plants that are going in there and their water use needs. Some of the areas then can start looking at converting to reduce the watering needs. So some of these areas are like the high water use, putting them down into low water use plants, taking and converting small and even narrow turf areas. Typically we'll see spray heads that are way overspraying, and because the sprinkler heads were never designed to really actually water for narrow areas, but people feel that they needed a 1.5 foot worth of narrow grass along some area. So there are alternatives. And the other thing that can help as far as reducing water waste is actually by putting bark mulch around the plants to help basically reduce the amount of evapotranspiration or evaporation that's taking place from the soils. Using bay-friendly principles approach then helps reduce costs also by not having as much debris to haul off the site. So you're maintaining the site debris on site and you're doing mulching with it if possible. In funding, we are often seeing water districts that are offering rebates either for reducing the amount of turf or improving the efficiency of the irrigation coverage. And so water districts, if you're able to go onto the internet, some of them will offer rebates for commercial and irrigation systems. You may find information also on water bills, and some of their customer service folks, if you contact them, will let you know that they have a water conservation manager who can help you meet out on a site and actually perform audits and look at opportunities to reduce water consumption. One important note, though, in time that you're looking at rebates, it's somewhat limited in time and amounts. Water districts have to apply for grants to get these rebates, and it's basically on a first-come, first-served basis, and they can run out fairly quickly. So they're somewhat tenuous on making sure that you get that. So again, contact the water district first before installing equipment. Check with them to see if they can perform an audit, find out what type of rebates, what their time frame is, and then follow their instructions for getting rebates. Last, we're going to finish up with a case study to kind of show you what we've experienced in working on a real-world site. This was in the East Bay in California, around the San Francisco Bay Area. And this site is quite large. When we look at it, it has 16 acres of turf, 14 acres of shrub, and about 12 miles of parkway, strips, and medians. The water rates in this water district have been going up about a 7% annual basis. It's about a 25-year-old irrigation system when we started working on it. A very low rainfall during the summer months. And on top of that was very compacted clay soils that tend to promote runoff and don't allow the water to really sink in very well. Some of the goals that the customer expressed to us was that they wanted to improve the irrigation efficiency, improve the aesthetics of the landscape. So if we're going to take this beautiful, valuable property and start doing anything with it, they wanted to know that it was going to maintain the value of the properties around that area. They were also concerned about the use of synthetic pesticides and fertilizer, as there are a lot of families in this particular instance. Their fiscal goals included reducing annual water costs and being able to actually complete the irrigation improvements within their budget. The solutions that we used for this site included reducing the turf areas, and what you're seeing in the picture to the left is a process called, and I'm drawing a blank, oh my goodness. Basically what they do is they take a cardboard material, and you're seeing that they're actually rolling it directly on top of the grass. This is actually called sheet mulching, is the term I was looking for. Sheet mulching, and what they're doing is they've mowed the grass down low, and then what they're doing is they're rolling out this cardboard that's available through different vendors, and they're rolling it out in a layer. And what that's essentially doing is allowing the grass to become the feeding material for the new plants that will actually be going in. They then come back and they do plant the 1 gallon, 5 gallon, 15 gallon plants and shrubs that are going to be low water use plants. In this particular case, they actually took the existing sprinkler system and just converted the existing sprinkler nozzles over to the rotary nozzles that we talked about earlier. They actually brought those up just a little bit taller to allow for overspraying, and the heads were able to spray over the type of plants that were selected, and the plants were selected to avoid growing taller than the spray heads would allow for coverage. This process of putting the sheet mulching on, then what they do is they come back with a layer of mulch around the plants, and they layer it on, and they put down about 3 inches worth of bark mulch. And what that does is it reduces the amount of evaporation from the soils, but as the sheet mulch breaks down over time, as well as the bark mulch, it actually starts feeding the plant material and the roots. Another benefit then is the fact that we're now not creating any kind of harmful byproduct from hauling off the the green waste. In fact, we actually took no materials from this site other than changing out the smaller sprinkler heads. So no debris was hauled off into the landfills. In there, we also use a process of organic services where we start using what's called compost tea and mycorrhizal fungi, and basically is designed to encourage positive microbes that grow down in the soil and actually help break down this stuff and make the soil healthier. Many times we'll find the soil has been fertilized with chemicals so long that there really is no beneficial life in the soils. By creating a beneficial environment, you're actually improving the root growth. And so by overspraying with what's called compost tea, you're actually injecting these positive microbes. They've taken mulch, they've heated it up to a certain amount, they've actually put a certain type of water through that, like a tea bag would be, and then they're applying that directly to the soils and basically jump-starting the soils with positive microbes. And so those things actually help reduce the amount of fertilizers and so forth that are needed because the plants are actually going in a healthy direction. The other thing that we put out on that particular site was irrigation systems that actually improve the efficiency. So in this particular area, we have a controller that we can enter the budget into each of the stations and determine whether the site is overwatering. So as we're going through, and I do, by the way, see some of the notes that are coming along, some of the questions, so I'll try and go back to those here at the end, but I want to make sure we get through this in the timely fashion. So some examples of bay-friendly also on these median strips. As you can see, the median strips there were at the end of a lot of the ends of the streets, and by converting those, what you see as bark mulch used to be the trees and a lot of the shrub, hedgerow, was mulched right on site and then redistributed around. And then lower water use plants were put in. Again, the sprinkler system was salvaged in such a way that once we get those plants established, in many cases we can shut off the irrigation system. The results for this particular site was a 27% reduction in water use and a savings of about 51,000. And so we can see the amount of gallons on an average in 2005 through 7 was 17 million gallons. And as we dropped it down in 2008 due to the projects and also adjusting for weather, because we don't want to take credit if the weather was cooler, we want to make sure that we show that it wasn't a result of us just being really good water managers. But after that, we're seeing a savings so that our usage now dropped to 12.5 million gallons. Customer also then received several rebates from the water district so that they could get some recognition. And so this is always another great byproduct of helping sites and work on water management projects, is when you can collaborate and have educational events. Customers who receive recognition often are supporting their employees. They're teaching about what is good water management. They can take those back to their individual homes and their communities and start to look at ways. And so it has a rippling effect and providing examples in the community. So at this time, we've gone through the main point of the presentation, and I'd like to try and tackle some of the questions that are up on the display here, so bear with me as I kind of go down through some of this stuff. Wanted to thank all of you folks for attending the webinar, so thank you for the comments on that. Water conservation for golf courses. So when you're looking at water conservation for golf courses, you are going to have certified auditors for golf. Irrigation Association in the United States does have a group of auditors that are trained specifically for golf courses. And if you're looking at golf courses, many of them are looking for water retention options. And they're they use a lot of monitoring systems that are fairly sophisticated to make sure that there's an appropriate amount of soil moisture and evenness. But the auditing is certainly one where people can get in and actually see what that performance looks like. The question came from Henry. You were looking for ideas about runoff or uneven parking spots. I'm not sure exactly what you mean by uneven parking spots, but a lot of the times the issue of runoff is twofold. You're dealing with either overspray or you're dealing with excessive run times. So where a sprinkler system can put down maybe 1.5 inches an hour, the soils may only be able to take in maybe 0.4 of an inch per hour. So if you're running a sprinkler system for 15 minutes, you're basically applying way more than the soil can take in. So typically what you would want to do is turn on the sprinkler system and observe it and watch until you see that the soils are starting to cause runoff. So you start to see that runoff take place. And then that would be your maximum run time and for a cycle. And then if you say, well, I still need 15 minutes and I can only run it for, say, 3 minutes, that means you need to break up that run time into 5 separate cycles. And you need to allow for a length of time between applications for that water to soak in before you start the next cycle. This is referred to as cycle and soak. If you're looking at overspray runoff issues, that's again where we look at opportunities to use inline dripper tubing. So we're applying water, 1, at a very low rate, and 2, it's right around the root zone. So you're not tending to see that runoff that takes place typically on spray zones. Where can you buy the little measuring cups? Irrigation supply warehouses, many of them have those available. You can also contact most of the agriculture colleges. I know the cups that we use for full audits come from Cal Poly in the San Luis Obispo area of California. There are other manufacturers of different cups. I think the yellow ones that we used were from a company called Niagara. But I think that probably the best recommendation would be to check in with your irrigation supply warehouses, and they can hook you up with those types. Again, by being a certified auditor, these programs are available for training for anyone. They teach you all the requirements of that. You want to put out at least a minimum of 24 cups to do an audit. They're found more accurate when you're having a larger volume of cups. So you want to make sure that you have an adequate amount to get an understanding of evenness. Can allowing lawns to grow taller, allowing a meadow to develop, save on water conservation? Yes and no. So a lot of times during the summertime, allowing the grass to grow taller will help with reducing evapotranspiration in that it creates its own shadow. Mowing turf at a really low level, unless it's specifically designed for that, when we look at, say, example, dwarf fescue, if we can mow that at about a 3 to 4 inch level during the summer, that actually creates a little more shelter or shade. If you're looking for a meadow effect, one of the things you might want to consider is what are actually types of ornamental or drought-tolerant type grasses. There is a company in California here called Delta Bluegrass that's actually been working with turf alternatives. And you can either treat it as a regular lawn, but it's using a lot less water than a standard lawn would, or you can allow it to grow, like you said, a meadow effect. The thing that you have to be aware of is that those still do need to be mowed. If they lay on top of each other for a significant period of time, it can actually cause damage to the turf area. What information is available to run outside fountains in a sustainable manner? You know, I'm not an expert in that area, so I can't really speak to running outside fountains. I can tell you that when we're looking at calculating water use for fountains, one of the things we'll tend to use is that 80% of ETO. And you're basically measuring the surface area of a body of water for square footage, and then you're taking that as you would your turf area and saying this is how much water this area is losing. Obviously, you start adding a fountain where the water is overspraying. We get a lot of that going outside the fountain. You know, it's harder, and in fact, we generally encourage a sub-meter. In other words, some kind of way of verifying the water use just specifically for the fountain to be able to detect leaks in the plumbing and the amount of water that is actually using. Otherwise, we're going to see issues where we can't tell the difference between a leak in a main line and a leak on the fountain. If you're looking for sustainable options, then I would probably either see if you can you know, use water catchment such as rainwater runoff systems, cistern-type programs to capture some of the water that's coming naturally and use that for water features. Anything that you can do to capture natural rainfall is good, though we understand it's also maybe a little more expensive because you're having to retrofit a site with piping and storage and so forth. That's a little harder to accomplish. Stephen, you said, how can I find a company or organization that might provide me with the best objective information regarding irrigation improvement in a commercial space? Again, I would start working with people who are certified professionals. So understanding what training they have at the very beginning of the presentation with some examples. So I would check in maybe with the state landscape contractors board, wherever you're at, and look to see what their professional levels are. The other way to be objective is to work with the water districts. They're the folks that you tend to have a little more integrity, an unbiased opinion, because they're not going to try and sell you anything. They can help you with both calculations as well as auditing a site and make general recommendations. At some point, you're going to have to work with the contractor, and if you're going to work with a contractor, you want to know that whatever equipment that they're putting in and so forth is at a professional level, and then probably would recommend an audit be done after the installation goes in if you want to verify that the performance is there. So again, that's part of that. Again, for California, if we're doing a large renovation, a lot of that is overseen by the water districts and the local jurisdiction. Bill, San Martin, you said, can you provide additional information regarding the formula to calculate the amount of water needed? Yes, we can provide that. What we'll need to do is get your contact information. I think probably the best way to go about that is I'll work with these folks to see if we can send that information along. There is an actual, the documentation for the state of California goes through not only the calculations, but also an explanation of the different calculations. We didn't create those. We may modify them a little bit to kind of help customers understand how their existing system is, because we understand not everybody can have the high standards that the state is setting. So if we're just trying to at least show them what their equipment in the ground right now should be doing as far as maximum water use, that's there. But we can certainly walk, try and create a link to the document that provides that kind of calculation. I don't know if there's any other questions. I've been rambling on here for a while here, so I don't know if there's anything else that we can open up and talk to people about. Mary, are you still out there?
I'm here, and someone raised their hand, and I was trying to, let's see, find it so then I can unmute them. And I think I unmuted who raised their hand, so you can probably try speaking.
Is somebody out there?
I unmuted them, but they didn't say anything. And someone wants to know if they can have your contact information. Do you want me to just send that out?
Our contact information here is on the last slide if you'd like to correspond with us. Certainly my email address, and if there's a question that you're asking and I can't provide a direct answer, especially on a lot of the horticulture and some of the more sustainable practices in soil management and plant health, I can certainly direct it on to, we have folks that are specialized in that area, so we can certainly pass that along.
And also, this has been recorded, so the webinar will be available on the corporate facilities website, and then I will also email it out to the entire CFC membership.
Okay. Well, I want to thank you for the opportunity to provide this information. It's always a pleasure to share, educational information. We look forward to additional dialogue with anybody up in the Northern California area. We want to let them know that we are available to assist in any way that they'd like. And thank you again.
Paul.
Folks, have a good afternoon or evening, and we'll talk to you later.
All right.